Hi-ho, chemistry guy again. So why do we care about oxidation numbers? Well, one of the reasons is if you're looking at something and you want to know if it's an oxidation or a reduction, oxidation numbers can tell you that. So let's see what that would look like. We have some arsenic thing here, and we're asked if this is an oxidation or a reduction. Well, what is the oxidation number of arsenic before and after? Following the rules we just learned in 281, if three oxygens have a total charge or oxidation state of -6, and our total is -1, then the arsenic here must be +5. And over on this side, oxygens are -2 each, so total of -4, yet our total is 0, so the arsenic here must be +4. So, now that we've done that, who cares about the oxygen? What happened to arsenic if its charge or its oxidation state went from 5 down to 4? Was it oxidized or reduced? Just the fact that the number went down makes me think reduction. This is the reduction of arsenic. It got reduced. Not too bad. If the number goes down, it was reduced. If the number goes up, it was oxidized. I'll do a couple more. There's another way to do this, which I will show you real quick, but let's get a couple reps in before we get to there. Permanganate ion, -8 from the oxygens. Total is only -1, so there must be +7 coming from the manganese. And on this side, we have -4 from our oxygens, so the manganese must be +4. Manganese went from +7 down to +4. It was reduced again. In hydrogen peroxide, remember this is a peroxide. This is that weird exception where the oxygens are -1 each, total of -2. And over here the oxygens are 0. So what happened to oxygen? It went from -1 up to 0, and if your charge goes up, you were oxidized. Hydrogen peroxide got oxidized up to molecular oxygen. And this is ethanol. What do we have going on here? There are 6 hydrogens, so we have a total of +6 from the hydrogens. I'm just putting it over here because this is where most of the hydrogens are. We have -2 from our oxygen, and then we have 2 carbons, and our total is 0. So I'm going to math this one. 2 carbons, +6 from the hydrogen, -2 from the oxygen adds up to 0. 2C plus 4 equals 0. Subtract 4 from each side. 2C equals -4. Divide by 2. C is -2. The oxidation state of carbon in ethanol is -2. And now I'm burning that because I need the space. In carbon dioxide, we have -2 from each oxygen, total of -4. Total is 0, so our carbon must be +4. So carbon went from -2 up to +4. Carbon has been oxidized. Number went up. Before I go any further, I'll show you another way we could have found these, and you might love this or you might hate it, but at least you'll know another way. You could take this half reaction and balance it just like we've been doing with our acidic medium stuff. So you could say ASO3, arsenic is balanced. I have 3 oxygens on the left and only 2 on the right, so the right side needs another oxygen. Now for hydrogen, I have 2 on the left, 2 on the right. I need 2 on the left, 2H plus. And now the really important part. What's our charge? We have -1 plus 2 is a total of +1 on the left, 0 on the right, so the left side needs an electron. And once you've placed that, you can say if this reaction starts out by being given an electron, what kind of reaction is it? We're gaining electrons, which means it's a reduction, if you're a Leo says Gur person, or you could say reduction is the gaining of electrons. That matches this as well. So either of those approaches will tell you that it's a reduction, just like the oxidation numbers will. And if we do that again for like C, all this is going to do is confirm what we already found, but let's do another one just to make sure. So C we found was an oxidation. If we balance it like it's a half reaction, we get 2 oxygens, that's fine. 2 hydrogens, we need a 2 here. And 0 charge plus 2 charge, we need 2 electrons on this side. This reaction is giving up electrons, and if you're losing electrons, that's oxidation, if you're a Leo says Gur person, or oxidation is loss of electrons works as well. So if you don't feel like learning anything new today, just balance these like half reactions and then use Leo says Gur, which you already know. If you want to do it maybe a little bit faster, then that's what the oxidation numbers are for, and that's how I'm going to solve the rest of these probably, because it is a smidge faster. But both ways are completely acceptable when you're answering our questions, as far as I'm concerned. Okay, let's see if I can do these at a bit of speed. +4 from the hydrogen. Total is +1, so the nitrogen must be -3. -10 from the oxygen here. So the nitrogens must be +10 total, so they must be +5 each. When you're determining this, you need to look at the numbers per atom, so the each number is actually the important one. In this case, it's simple to figure that out, but it won't always be, so just remember that the each numbers are the ones you should be comparing. Did you notice this reaction isn't balanced? Good thing about oxidation numbers, you don't care if you're doing the oxidation number method. If we were balancing this like a half reaction, you would absolutely have to start by putting a 2 there, or else your balancing would be all broken. But in this case, nitrogen starts with a state of -3. It goes up to +5. That's up, so nitrogen is being oxidized. Oxalate ion, we have -8 charge from our oxygens. Total is only -2, so the carbons must be contributing +6 or +3 each. And in methane, we have +4 from our hydrogen, so the carbon must be -4 to make our total 0. +3 for each carbon, going to -4 for each carbon. That's way down. That is definitely a reduction. CrO3+, we have -2 from our oxygen. Total is +3, so we must be getting +5 from our chrome. It's chromium, but I get lazy and say chrome sometimes. And here in dichromate, we have -14 from our oxygens. The total is only -2, so we must be getting +12 from our chromium, so that's +6 each. We went from +5 up to +6. Up is oxidation. Hope these are going okay for you. This complicated thing, we have 6 oxygens, that's a total of -12. 4 hydrogens, that's a total of +4. And our total is only -1, so we have 4 plus whatever I is, -12 is coming out to -1. 4 minus 12 is -8. I minus 8 equals -1. Add 8 to each side. I equals 7. So our iodine is +7 on the left side of this. And what is it on the right? We haven't seen a lot of these, but iodine is a pure element, and pure elements have oxidation state 0. So iodine went from +7 down to 0. Down is reduction. And last one, gold turning into gold cyanide. Well, we were just talking about pure elements and how they're zeros. Gold by itself is also a 0. And on this side, this has not come up a lot, but the cyanide ion by itself, like Cn, has a charge of -1. So we can treat this entire thing like one chunk. We don't have to look at carbon and nitrogen individually. We can say Cyanide ions are -1. There are 4 of them here, so we have a total of -4 charge from our cyanides, and yet the total for this entire complex is only -1. That means the gold must be contributing +3. So our gold went from 0 up to +3, and if your oxidation state goes up, you have been oxidized.